Okay, today I'm going to talk about this atmospheric measurement called dew point and why it is a better measurement of how comfortable you'll be when you step outside versus humidity. So probably the best way to look at it is we'll go to the Bureau of Meteorology and look at Adelaide observations. So you'll see here I'm actually closest to Adelaide Airport where I am, and it's fairly feels quite sort of sticky and a bit muggy tonight. So this is what prompted me to do this video, and I can explain to you why it feels a bit uncomfortable. Like, it's not majorly uncomfortable, but it's just, you still got that little bit of stickiness in the air. And the easiest way to explain this is the relationship between temperature, dew point and relative humidity. So if you look here at Adelaide Airport, we've got a temperature of 24.2 degrees. My apologies for all the US viewers that are using Fahrenheit, but for the rest of the world, we use Celsius. So here we go. So we've got 24.2 degrees temperature. Apparent temperature won't bother about. Then we move across to the next column, 16.9 degrees dew point. Now that's fairly high. Anything above 15 degrees you start feeling uncomfortable. Anything above 20 degrees it's really, really uncomfortable. It was around, I think it was around 22 degrees the other day, and I just couldn't get to sleep. Right, so, and you see here the relative humidity is 63%. Now, let's define what is this thing dew point. Now what it is if I got a sheet of glass, and in this current situation here at Adelaide Airport, if I decrease the temperature from 24.2 to 16.9 degrees, you'd have dew forming on the glass. It's basically the temperature where all the water molecules lose enough energy that they condense. They condense on the surface. So that's why you see dew on grass, dew on glass as well, glass surfaces, any sort of surface like that. So a nice example is like when I sort of think, oh, is it just me, or is it, am I imagining that it's humid and sticky? What I'll do is I'll open the freezer door and you'll see like mist, because what it's doing is it's cooling the immediate air around, and you're getting that mist. So it's all got sort of a dew point. The dew point's quite high, so therefore the freezer doesn't have to lower the air temperature by too much to actually condense the water molecules into from the gaseous vapor state into liquid. So that's basically what's going on. And once you understand this, you'll understand a whole lot of different atmospheric phenomena like fog and how clouds form and all that sort of thing. Because basically, when clouds form, you've got a high humidity, but as the air is rising, because hot air rises, the water droplets will condense and form clouds. And when the clouds are saturated enough, you'll get rain. So it's a very interesting concept. You'll never hear it on the weather forecast, but I always look for it. I always look at, looks like it's refreshed there. I always look for it when I'm looking at how comfortable it is outside. So you see here. So what we got here is at Adelaide Airport, 64 degrees relative humidity. So basically, if the temperature was going down, you'd have the same amount of water vapor in the air. Relative humidity would go up, and that's why relative humidity isn't a really good way of working out how comfortable it is outside, because you can have a very high relative humidity but a low temperature and a low dew point. You see, so if this dew point was say 10 degrees, you'd still feel comfortable at say 20 degrees with the same relative humidity. So yeah, it's all related. And the easiest way to probably conceptualize this is, let's go full screen so I can explain this better to people. So just think of water molecules in the air. So there's two little water molecules. Now the thing about dew point is, and relative humidity, as the temperature increases, you imagine that the density of, like, the water molecules will move further apart. So you can actually fit more water molecules in when the temperature increases. So you can have more water in the air, and that's how it's all related. So as the temperature decreases, the water molecules move closer together, and you get the condensing. And as the temperature increases, they can move further apart, and you can actually fit more water molecules in the same area. So that's how everything's related. So once you understand that, it's pretty easy to figure out what's happening with atmospheric conditions. So so that's why you can have a as the temperature increases, usually the relative humidity will go down, all right? Because the relative humidity is like the partial pressures of the water vapor in the air. So we won't get into that, but it's easier just to think of it this way: as the temperature increases, you can fit more water molecules in the same volume of air. Right. So and that's why it's you get a higher pressure as well. And that's why as you move up into the upper atmosphere, the pressure gets lower, water molecules start condensing again, and with the same relative humidity, they'll condense and form clouds. So so I hope you enjoyed that. That's my layman's explanation of relative humidity and dew point and so forth, and temperature. So dew point is the go-to measurement I go to now, and if it's above 15 degrees, I sort of go, okay, that's why I'm feeling a bit muggy and sticky and icky tonight, because it's above 15 degrees. And so I think 15 degrees is around, I think it's 60 Fahrenheit. Let's go into the let's get it. We can get into the Fahrenheit to Celsius calculator. Celsius to Fahrenheit conversion. There we go. So I always think around 15 degrees, 59 Fahrenheit. So around about 60 Fahrenheit is above a dew point above around 60 Fahrenheit. It starts getting a bit sticky and uncomfortable. So now when you're in like Florida in the middle of summer, you're probably feeling it, because the dew point could be well, actually let's look it up. Let's look up dew point, say in let's see, it'll be quite muggy in, say, Singapore. Let's look up dew point Singapore, and you'll see what I mean here. Dew point 74 Fahrenheit. So let's zoom this in a bit so you can have a quick look. There you go. So Singapore for the next 48 hours. Dew point 74 Fahrenheit. Singapore is a good example, because I don't think I've ever been to Singapore where it's not really muggy and disgusting. So you can see here the relative humidity is 83%, so the air is very saturated. And it relates to the dew point. And what does it say the actual temperature? Let's see. Let's look up temperature. Temperature Singapore. 29. So it's all related there. I think it's 75% humidity there, but it's all related. At a higher temperature, you can fit more water in the air, so you can have a higher humidity. See, precipitation 0. So that's how it's all related, and the dew point. So if you're looking at a high temperature and a high humidity, the dew point is going to be high too. Because usually, as the temperature rises, humidity goes down, because you're pushing the molecules apart, the water molecules apart with the higher temperature. Now you got more energetic air molecules pushing that. Oh, let's go get my thing back. So I hope you're understanding this. It's not too hard a concept to. Sometimes it'll click in your head, and then you'll just get it. People that are having trouble understanding what I'm saying, it'll just click one day and you go, okay, it all makes sense. So you'll see that dew point there is quite high. 74, that's very uncomfortable. Where else would have a high? Let's contrast it to, say, I'm just thinking of where it would be dry at the moment. Maybe, let's see, over in the US. No, I'm thinking, where would it be dry at the moment? Dew point. Sierra Nevada, Sierra Vista, Arizona. Dew point 30. Yeah, see, here we go. So if you see here, the humidity is 96% with a dew point of 35.6 degrees. So that's it's fairly high, 96%. Wow. Dew point 29 Fahrenheit. That's what gets me about these these weather channels. They all vary. That's why I tend to go to, for my area, I tend to go to the Bureau of Meteorology, because they are actually, they're the government issued weather stations. So it's all going to be correct. This is where we get all our if we've got a temperature record, this is where we get it from, the Bureau of Meteorology. So that's how it all works. So you can look through the different areas in Adelaide and see where it's going to be the most muggy, which is basically where I am. Now, Edinburgh, 17.5 degrees. Yeah. So what are we looking at here? I wanted to find one that's got a low dew point. Let's put current lowest dew point in the world. See if it comes up. This is the lowest recorded. See, we hold the record here in South Australia. The world's lowest recorded relative humidity value occurred at Coober Pedy in South Australia, my state. Desert, when the temperature was 93 degrees and the dew point was minus 21 degrees, producing a relative humidity of 1%. So what's that saying? What's that actually saying is there was very, very, very little moisture in the air, and you'd have to. So this is in obviously in Fahrenheit, 93 degrees Fahrenheit. It's not 93 degrees Celsius. That'd be impossible. So you'd have to go to minus 21 degrees for that small amount of moisture in the air to condense on a plate of glass, basically, or a surface. So that's. I hope you can see what I'm showing you here. It's all related. What is considered a low dew point? So there we go. Most people are comfortable with a dew point temperature of 60 degrees Fahrenheit or 16 degrees Celsius or lower. A higher dew point, for example, of 70 or 21 degrees Celsius, most people feel hot or sticky because the amount of water vapor in the air slows the evaporation of perspiration and keeps the body from cooling. Yeah, that's another good point as well. And that's why evaporative coolers don't work when there's a high dew point, because the air is too saturated and for that temperature, and you won't get any evaporation from the air conditioner, and therefore it won't cool the air. Let's see what else we've got here. It's very interesting. So Wikipedia's got the definition as the dew point is the temperature which the air must be cooled to become saturated with water. So it's basically what I was saying as well, but hopefully I've said it in a very layman's terms and you can all understand it. And dew point will be your best friend. Dew point will be your best friend, that's for sure, because I'm always going to look at the dew point when I'm working out how comfortable it is outside and what I should be wearing. Okay, guys, hope you enjoyed that. I hope you really enjoyed that, because I only learned about dew point maybe a couple of years ago, and I think it was during a World Cup qualifying match, and they were playing it in either Malaysia or Singapore, and the guys were just totally sweating, and I looked at the weather forecast, and I think it was like 28 degrees or something Celsius, and I thought, well, that's not really that hot. But the relative humidity was like 96% or something, and the dew point was like 28 degrees Celsius, which means it was very, very oppressive, because the temperature between the current temperature and the dew point was very close together, which means the air was extremely saturated. You only need to bring the temperature down for it to be condensing the water vapor. So I hope you can see the relationship between relative humidity, dew point, temperature, and pressure, because it all ties together, and you can work out all the different weather phenomena from there, such as fog and also you can work out why we're having extreme events with global warming, climate change, global warming, because as the temperature increases, you're going to have more evaporation, and this is probably one of the reasons why we're getting more humid weather coming in Adelaide as well, because there's more moisture in the air, right? Higher temperatures, the more things evaporate, more moisture in the air, so you're going to get extreme weather events because you'll get temperature gradients for higher winds. You get more water vapor in the air for bigger cloud formations, more rainfall, probably more, and because you've got the different wind patterns and everything, you're gonna have these huge clouds moving around the globe in different patterns. So where before you could probably predict where there was going to be rainfall, it's probably going to get more difficult now. So you get more extreme weather events, higher rainfall events, more flooding, that sort of thing. So all these climate change deniers really think of it logically. It's once you've digested this video, you'll probably understand more why global warming isn't just a hoax. It's actually happening, and it's quite scientifically very logical why it's happening as well. It's basically climate change. It's not weather change, because weather will vary, but we're looking at overall climate, and Adelaide is getting a little bit more subtropical. It used to be very dry, as you saw here. What was this? I think it was 2016. We had 2011 was when we had that extreme weather event there in Coober Pedy. We had the greatest had the lowest dew point ever recorded. What was here we go. Relative humidity, and dew point of minus 21 degrees. Incredible. Okay, guys, I'll leave it there. So leave your comments and questions below if I haven't covered anything. I might have made a couple of mistakes along the way as well, so point those out if you want. It's, sometimes I get confused myself, sometimes with the relationship between these things, but hopefully I've explained it well enough that you understand what I was talking about. Okay, cheers, bye.